Chapter 3, Exercise 19. Let A be the function containing the two relations, the first being the empty set, comma, the set containing the empty set and the set containing the empty set. And the second ordered pair being the set containing the empty set and the empty set. Evaluate each of the following. A of the empty set, the image of A under the empty set, the image of A under the set containing the empty set, the image of A under the set containing the empty set and the set containing the empty set, the inverse of A, the composition of A with A, the restriction of A to the empty set, the restriction of A to the set containing the empty set, the restriction of A to the set containing the empty set and the set containing the empty set, and the union of A. This is a horrible exercise. I hate it. I despise it. I just want to lead with that. Why would you do this to me? But let's just do it. Why not? So A of the empty set. One thing that I think is important to note at the very beginning is that A, first of all, contains only two ordered pairs, and note that all the elements in the domain are distinct. That is, everything on the left-hand side of these pairs is distinct. Hence, A is not just a relation, it is also a function. So, what does that mean? It means that A of the empty set is equal to the union of the set Y such that X comma Y is an A. That's going to be the union of the set hold on. Oh, sorry. A of X would be this, right? So A of X is the union of this set right here, which is going to be the union of, or rather, for X equal to the empty set, A of the empty set is the union of Y such that the empty set comma Y is an A, which is equal to the union of this right here. Of this set. Is that right? I'm missing one. Okay. Cool. And what this is going to be is just equal to the set containing these things. Oh my. Right? And just for future reference, this is equal to the power set of the empty set. Alright, so that's one. Now let's compute the image of A under the empty set. So what this is going to be is this is going to be equal to the range of A restricted to the empty set, which is equal to V such that there exists some U in A such that U F phi. I'm just ripping these definitions straight from Enderton, by the way. And this is going to be equal actually to A of U such that U is in the empty set. Oh, sorry. That's the danger of copying definitions. I almost got that wrong. Okay. The range of A restricted to the empty set, which is equal to this set right here, which more importantly is equal to this. Note, is only true if A is a function, which it is, as we showed earlier in the video. So it's going to be equal to the set of A of u such that u is in the empty set, but note already that there is no u in the empty set. Like, this is not a thing. The empty set is quite literally the set containing nothing. So yeah, we just have the empty set as the image of A under the empty set. So long story short, this is what you get. Okay, now what is next? It is the image of A under the set containing the empty set. Now this is different, right? It's going to be A of this is going to be equal to the range of A restricted to the set containing the empty set, which is going to be equal to V, such that there exists some u in the set containing the empty set, such that UAV, which again is going to be equal to A of u, such that u is in the set containing the empty set. Again, only works with A if A is a function, but it is, right? Now, what is this? So, we can compute A of u for every element u in the set containing the empty set. So this is actually going to be the set of A of the empty set, which we showed that this specifically is the power set of the empty set, or this, right? The set containing the power set of the empty set. I'm just going to leave it at that. Right, let me add some more pages before we move on. And let's keep going. D. Alright, so there's the image of A under the set containing the empty set and the set containing the empty set. Okay. Right, so same thing. And I'm just going to call this the power set of the empty set to save up some word. And I'm going to skip the formal definitions and just go to A of u, such that u is in the power set of the empty set, which is going to be equal to A of the empty set, comma A of the set containing the empty set, right? And now this is going to be equal to A of the empty set is going to be the power set of the empty set, and A of the set containing the empty set is going to be the empty set. So it's going to be equal to power set of the empty set, comma empty set. And there you go. That is the image. Now E is going to be the inverse of A. And if A is equal to this right here, then A inverse is just the result of swapping places for each one of these. It's going to be power set of the empty set, comma empty set, comma empty set, comma set containing empty set. There you go. That's the inverse. Now F is composition of A with A. I see now. So the latency is due to the pen, not the iPad. This like off-brand pen I have. That's why it's slow. It's not that my iPad is slow. It just takes a while for the input to come in. Alright. So the composition of A with A is going to be the set of u comma v such that there exists some t such that u a t and t a v. Right? So let's see. How do we go about this? We just find the elements that chain together. So we can have this, right? This has this as its range, and then this has, sorry, A of the set containing the empty set is equal to the empty set, and then A of empty set is equal to power set of empty set. So A of empty set is equal to A of set, no, sorry. Set containing the empty set is equal to A of empty set, which is equal to power set of empty set. So that is the only thing we can compute right now, or the only thing that we can find that would match that. So there you go. It's gonna be set containing empty set, comma, power set of empty set. And there you go. That is a composition of A with A. G is, what is G? The restriction of A to the empty set. I think we already argued this, but the restriction of A to the empty set is u comma v such that UAV and U is in the empty set, but this statement is nonsensical, so this is just the empty set, right? There is no U that satisfies that. I do not know my alphabet apparently. Okay. H is the restriction of A to the set containing the empty set. And this has to be U. That is not a good U. Such that U, A, V, and U is in the set containing the empty set, which is going to be the set of empty set, comma, power set of empty set. Why? Because empty set is in the set containing the empty set. and this is the only pair in A. That satisfies this, right? There you go. Cool. Next up, HI. The restriction of A to the set containing both the empty set and the set containing the empty set. So this, if you do a little thinking, turns out to be equal to this restriction of A to its own domain, right? And that should just, give you A. But we can also do the more formal work from the definitions. So this has to be equal to set U comma V such that U A V and U is in set containing the empty set and the set containing the empty set, which is equal to first for this element it's going to be empty set comma power set of empty set, and then for this element it is set containing empty set comma empty set. There you have it. That is I. Now J, I think that might be the last one. Yep. The union of A, which we've worked with a lot of unions before. I think it's okay if I skip the formal definition. And essentially it's just going to be you take everything both in the domain and the range and you just stick them all in one set. So it's going to be set containing the empty set, power set of the empty set, the set containing the empty set, and the empty set again, which, as you well know by now, we can omit repeated entries, and we can also rearrange it so that it looks nice. So it's going to be this set and the power set of the empty set. And if you want to expand the power set of the empty set, it ends up looking like this. And there you have it. The union of A. That is all for this one video. That is all for exercise 19. Hope it was helpful. And I'll see you in the next one. Bye bye.